Newton's first law. Newton's first law of motion says that an object will stay in constant motion until a net force acts upon it. An object at rest will stay at rest until a net force moves it. An object moving at a constant speed will keep moving in a straight line at that speed. If a net force acts upon it, it can change speed or direction. Objects tend to resist any change in motion. This is known as inertia. Objects with greater mass have more inertia than objects with less mass. Your body's inertia is what pushes you against the side of a car as it goes around a curve. Your body tends to keep moving in a straight line. Then your car turns. It takes a moment for the motion of your body to adjust. A full truck has more inertia than an empty truck. It will take more effort to make the heavy truck stop or speed up. A space probe is an example of Newton's first law. Inertia keeps the probe moving through space. Probes need very little fuel after they get into space. There is no net force to slow them down. They usually need fuel only to change direction or to slow down. Inertia will keep the football moving after the kick. Eventually, gravity will pull the ball to the ground. The football stays at rest on the tee until the force of the kick causes it to move. The vehicle stops when it crashes, but the test dummy keeps moving because of inertia. Only the seatbelt holds it back. Newton's second law. Newton's second law of motion describes how net force, mass, and acceleration are related. Acceleration is the rate at which the velocity of an object changes over time. The net forces acting on an object can change its velocity. You may think of accelerating as speeding up, but acceleration can mean speeding up, slowing down, or changing direction. This formula shows Newton's second law of motion. Force equals mass multiplied by acceleration. The formula can be written as F equals m times a. To find an object's acceleration, the formula can be written as a equals F over m. To find the mass of an object, the formula is written m equals F over a. The net force on the box equals the mass of the box times its acceleration. The greater the net force on the box, the greater its acceleration will be. The greater the mass of the box, the less its acceleration will be. Newton's third law. Newton's third law of motion states that when one object pushes or pulls on another, the second object pushes or pulls back on the first object. This is also called the action-reaction law of motion. Action-reaction forces are always equal and opposite. They always come in pairs. You can see this law at work every day. When you see an object move because of a force, there will also be an equal and opposite force. It is impossible to have one force without an equal and opposite force. Have you ever ridden in a bumper car? A moving car may bump into a stopped car. Both drivers will feel the force of the impact. The force slows down the moving car and puts the stopped car in motion. Bumper cars can exert equal and opposite forces on each other. Force of the red car on the purple car. Force of the purple car on the red car. What are simple machines? Machines and work. A machine is a device that changes the direction or amount of force needed to do work. Simple machines have only a few parts. 4 simple machines are the pulley, the wheel and axle, the lever, and the inclined plane. Machines do not reduce the amount of work that needs to be done. They can make it easier to do the work. A machine can allow you to use less force to do work. In exchange, you must apply that force over a greater distance. This balance lets the total amount of work stay the same. A machine might make work easier by changing the direction of the force. This pulley changes the direction of the force. Pulley. A pulley is one type of simple machine that changes the direction of the force needed. A pulley is a rope or cable that runs around a grooved wheel. Flagpoles and pulleys. Flagpoles use pulleys, and so do some kinds of curtains. A block and tackle is a system of pulleys. The block and tackle can make it easier to lift heavy objects. Wheel and axle. A wheel and axle has a round object such as a doorknob and a shaft. The wheel and axle reduces the amount of force needed to do work. Think how hard it would be to pull a bucket of water up and out of a well. Instead of pulling the bucket in a straight line, you turn the crank in a circle. The steering wheel of a car is another kind of wheel and axle. The crank on this well is a kind of wheel and axle. Lever. A lever is another simple machine that changes the direction of a force. A lever has a bar that rotates on a fixed point. That fixed point is called the fulcrum. Levers use the bar, the fulcrum, and the force that you apply to move a load. A seesaw is a lever that changes the direction of force. To use a seesaw to lift a box, you push down at one end. The box goes up at the other end. The amount of force needed to move the box will change if you change the position of the fulcrum. The farther you are from the fulcrum, the easier it is to push down on the lever. Look at the picture below of the person using a lever to lift a box. The person applies less force in the weight of the box, but the person must apply that force for 1 meter. The box rises only 0.5 meters. Other simple levers. Many everyday items have levers. How do the parts of these items help people do things? Inclined planes. Have you ever carried something heavy up a flight of stairs? Rolling the load up a ramp would be much easier. A ramp is a type of simple machine called an inclined plane. It is a flat surface with one end higher than the other. The inclined plane can be a big ramp that a car might go up, or it can be a small wedge, such as a doorstop. Pushing a wheelchair up a ramp uses less force over a longer distance than lifting it up in the steps. Complex machines. Many machines combine two or more simple machines. These are called complex machines. They might use burning fuel, gravity, human power, electricity, or magnetism to do work. Look at the picture of the go-kart. It uses many simple machines to move the driver along. A go-kart is a complex machine. The go-kart's steering wheel is a wheel and axle. The simple machine is connected to levers that run the front wheels. The pedals the driver uses to control the engine and brakes are also levers. Gears, a type of wheel and axle system, connect the engine to the cart's rear wheels. The engine itself is a complex machine. It is made up of many small, simple machines. Glossary. Acceleration. The rate at which the velocity of an object changes over time. Equilibrium. A state in which all forces acting on an object balance each other. Force. A push or pull that acts on an object. Inertia. The tendency of an object to resist any change in motion. Machine. A device that changes the direction of force or the amount of force needed to do work. Power. The rate at which work is done. Velocity. The speed and direction of an object's motion. Work. The energy used when a force moves an object.